Hello and welcome to another Unarculus production! Yay! Today we are going to integrate using everyone's favorite thing from Algebra 1, completing the square! Yay! Okay, so let's get started by remembering how we complete the square. Here we go! Alright, so recall how to complete this square. So completing the square basically involves you writing or being able to then factor something as x plus or minus a quantity squared, right? So that's basically what we're trying to do. We're trying to force the polynomial or the quadratic to factor in this way. Okay, so we can do that, if you recall, by a couple of things. Number one, first thing, a has to equal 1 to complete the square. All right, and by a, we mean a, b, c, right, in a quadratic, okay, ax squared plus bx plus c. All right, and then to complete the square, you're going to take the b term, divide by 2, and square it. Okay, that is the number that completes the square. That completes the square. And in the meantime, all the while, the goal is to do this and make it factor as such without actually changing what the polynomial or what the quadratic was originally equal to, right? Just changing the way it looks. So for example, if you look at the first one here, I have x squared minus 8x plus 5. That certainly will not factor like that. Okay, so what I'm going to do is I am going to take the b term, which is negative 8. All right, I'm going to take negative 8, divide by 2, and square it. So that gives me negative 4. I square it, I get 16. Okay, so what I'm going to write is I'm going to write 8x squared, or x squared, minus 8x. Now I'm going to add 16 into this polynomial. Okay, because this is the number that completes the square, but I still have a plus 5 here, and now I just can't start randomly adding numbers here to expressions. So I added 16, I also have to take 16 away. Okay, so you added 16 in, you got to subtract 16 out. All right, so now what it does is it allows me to take this first half of the quadratic, x squared minus 8x plus 16, and factor it, okay, as such. All right, and that's pretty easy to do. Okay, so this will factor as x minus 4 quantity squared. And then I now have a 5 minus 16, which is negative 11. Okay, now the other thing I need you to take note of is the following. If I look back at the second line again, and I were to combine all the like terms, I would get back to the first line. Okay, because completing the square doesn't actually change the values, okay, of the quadratic expression. It just changes the way it looks. So the x squared minus 8x plus 5 are still intact in this line, right? It just looks different because we added 16 and took 16 away. Okay, so this is how you would complete the square. All right, so you complete the square. This is what we would get after we completed the square. Now you can do some things with it. If I set it equal to 0, I could solve it, right? There's a lot of things that I can do. But hopefully you notice the fact that it now says here x minus 4 squared. It's some quantity in terms of a variable being squared minus a number squared. And that should sound familiar to you because in the last section, we dealt with things similar to this line, not exactly like it, but similar to it, and it gave us inverse trig integrals, right? So that's what we're trying to do here. All right, so let's go ahead here. Okay, let's do one where the coefficient is not 1. All right, so I think the easiest way, there's a couple ways that you can go about doing this. I'll show you both, and then you can decide whatever it is you want to do. The first thing you can do is factor out the negative 2 out of all 3 of these terms and then play the game. So I could take negative 2 out of everything, and I'd have x squared plus 6x plus 9 over 2. Okay, and now I would have to complete the square inside the brackets. So I would take 6, divide by 2, and square it. So that's 3 squared. That's 9. Okay, so 9 is the number that completes the square. So I'm going to write x squared plus 6x plus 9. I'm going to add 9 here. Then I have this 9 over 2, and I'm going to take 9 away from it. Okay, and that would give me x plus 3 quantity squared, right? If I factor the x squared plus 6x plus 9. And then 9 over 2 minus 9 is, let's see, a negative 9 over 2, right? Okay, that's a negative 9 over 2. I think, yeah, negative 9 over 2. Okay? All right. That's one way that you can go about doing it. Okay, that's one way that you could go about doing it. And then, if you multiply this out, right, you would get back to where you started again, right? You could see in this line, it's a little easier to see in this line here. The 9 minus 9 is 0. And then if I multiplied everybody by negative 2, I'd get back to where I started. Okay? All right. So that's one way you can do it. You can factor out the a term out of everything before you start. The other way to do it is you can factor out the a term just out of the first two terms and then play the game that way. So let me show you that real quick. So you could take out the negative 2 just from the x squared and the negative 12x, okay? And then leave the negative 9 on its own, but it does involve a little extra step that you have to remember. So if I take the b term, divide by 2 and square it, sure enough, I'll get 9 again. So 9 is the number that completes the square. So a 9 goes here. Now, when I want to put the number outside here, okay, I have to account for the fact that I never took the negative 2 out of the negative 9 that's out here. So I'd have to do negative 2 times 9, which is negative 18, and I'd have to take 18 away from it. Okay, I'd have to take 18 away outside. So I'd have now negative 2 x plus 3 quantity squared minus 27. Okay, minus 27. All right, so that's something you do have to consider. You can do it either way. It works both ways. All depends on how you want to go about doing it and how you want to think about it. Whatever way you do, I would stick with it every time. Okay, so they're just a little more complicated. All right, so here we go. Let's evaluate this integral. The integral of dx over x squared minus x plus 2. All right, now the big issue with this is, and if you run through your integration techniques real quick, you can't just use substitution on it, because if you let u be x squared minus x plus 2, its derivative is 2x minus 1, and there's no 2x minus 1 to be seen in that. You can't long divide this because there's nothing in the numerator, well, there's just a 1 there, to long divide it into. So that's not going to work. Okay? You can't use inverse trig, at least not at the start, because inverse trig would involve, for example, this looks most like arcsin, but arcsin would be a squared plus u squared, and you can't write this as some quantity that's being squared. So that's not going to work. So really, completing the square for a lot of people is really the method of last resort. There's nothing else left for me to do. I don't know what else to do with this, so I'm going to try completing the square. And that's what we're going to do here. So we're going to complete the square over here. We are going to complete the square, x squared minus x, and we'll leave out the 2. So we'll leave a couple spaces here. We're going to take negative 1, the b term, divide by 2 and square it, and that's going to give us 1/4. So 1/4 is the number that completes the square. We are going to add 1/4 here, and then we're going to take it away over here. Now, we need to know how this this part of the quadratic will factor. Okay? And if you remember, there's a trick that you can use. When you take the b and divide by 2, this number that you get is the factor that you should use when you actually go and factor this expression. So we're just going to write x minus 1/2 quantity squared. And we got it from right here before we actually squared the negative 1/2. That's the number that makes it factor. It works every time. Okay? And then we have plus 2 minus 1/4 is, let's see, that's 7/4. All right, so now we are going to rewrite this integral that's up here as the integral of dx over x minus 1/2 squared plus 7/4. All right, and now you're actually in a form where it says du over a squared plus u squared, or at least you could write it that way. All right, it takes a little bit of work, but you can do it. So if we let u, or let's rewrite this first here a little bit. So we have dx over x minus 1/2 squared plus 7 over 4 has to be written as a quantity squared. So that would be radical 7 over 2 that's being squared. Okay? All right, it's radical 7 over 2 that's being squared to give me 7/4. All right, so they don't all necessarily come out to be even. All right, so we're going to have u equal to x minus 2, or I'm sorry, x minus 1/2. Our a is going to be equal radical 7 over 2. Du is equal to dx, so it's a straight swap, du for dx, no Beach Boys. And then our next integral is going to look like du over u squared minus radical 7 over 2, plus radical 7 over 2 that's being squared. That's the arctan rule. So this is going to be 1 over radical 7 over 2, which we'll clean up in a minute. Arctan of, well, it would be u over radical 7 over 2 plus c. And then if we clean this all up, let me do it. Yeah, we can do it here. So we have 2 over radical 7, arctan of 2. U is x minus 1/2 over radical 7 plus c. And that's the correct answer. Okay? So a little messy. You don't have to rationalize the denominator. We really don't do that in calculus at all. You can just leave this answer like this, and you're all done. All right? All right, let's see what we have here next. Okay, so here's one where the coefficient is not 1. And again, we're in the same boat we're in the last problem. There's really nothing you can do with this that will make this easy to calculate. So the only thing we really can do is complete the square. All right, so what I'm going to do is I am going to take the 2 out of everything, I suppose, and I'll have 2 quantity x squared minus 4x, skip a space, plus 5, and leave some blanks. So we are going to take the middle term, the negative 4, divide by 2, not a 4, and square it. And we get negative 2 squared, which is 4. So we're going to add 4 up here, then we're going to take 4 away. Remember, we took the 2 out, so that's okay. So we have 2 times, in parentheses, we have x minus 2 that's being squared plus 1. Okay, so this integral in the next line is going to become dx over 2 x minus 2 squared plus 1. Now, this looks like an issue, the fact that we have this 2 sitting down here, but it's actually not. It's actually the least of our concerns, because really we can take, this is really just a 1/2 that we could stick outside the integral, because we don't really need it there. It's 1/2 times whatever's here. So we can rewrite this as 1/2 the integral of dx over x minus 2 squared plus, that's going to be a 1 squared, and then we're going to let u be x minus 2. So du is dx. Straight swap for du and dx. We're going to have 1/2 the integral of du over u squared plus 1 squared. That makes u itself and a1. And we're going to use the arctan rule. So this is 1/2 times 1 over 1 arctan of u over 1 plus c. But u is x minus 2 plus c. And there is your correct answer. Okay, so it's not so bad to deal with the a terms when they have to come out. All right, and one more here. So here we have the integral of dx over radical 3x minus x squared. Again, this is another one you really can't do anything with. You can't let u be 3x minus x squared. Certainly would be your first instinct. Its derivative is 3 minus 2x. That's not going to help you at all. All right, so this is another one where we are going to complete the square. So we're going to take the negative out. You do have to take the negative out. We'll rewrite it first. So it's negative x squared plus 3x. We do have to take the negative out of there, okay, because it does belong to what's going on here. So we take the negative out, and that gives us an x squared minus 3x. All right, so now we are going to take the middle term, which is negative 3. We're going to divide it by 2, and we're going to square it. That gives me 9/4. So I'm going to add 9/4 to this, and then I'm going to take 9/4 from it. Okay. And when I do that, that will give me the opposite of, this is the term that will factor, the x squared minus 3x plus 9/4. And it will factor as, let me put some brackets here, x minus 3/2 squared, right? The 3/2, negative 3/2 coming from there right before we squared it. And then we still have the minus 9/4 that's laying here that's not needed for the factoring. Okay, so now the rule, remember this is now going back in the radical, so this is now the integral of dx over radical negative the quantity x minus 3/2 being squared minus 9/4, okay, all in the bracket there. But if you remember, the rule is radical a squared minus x squared. This does not say that, but if we distribute the negative that we took out back in, it will say that. So we'll have dx over radical 9/4 minus x minus 3/2 squared. And the 9/4 we can rewrite as 3/2. So let's do that. So we have radical 3/2 that's being squared minus x minus 3/2 that's also being squared. So a is going to be 3/2 and u is going to be x minus 3/2. Its derivative is dx, so straight substitution here. And we're going to have the integral of du over 3/2 squared minus u squared. And this is an arcsine problem. So this is going to be arcsine of u over 3/2, which is really going to be 2/3 plus c, only because I'm running out of room. So this is going to be arcsine of 2 x minus 3/2 over 3 plus c. And there is your correct answer. Okay, and that's how you integrate by completing the square. And as always, thanks for clicking. I hope you enjoyed this Narculus production.